Welcome dear students. The word perfection denotes arrangements. Anything's arrangement is very essential. Not only man-made things, the God created natural also maintain the perfections. So unless perfection, we can't get anything. Not only here, suppose you think about our body, it is the best example of perfection due to good arrangements. Consider our eyes is in our face. Suppose in somewhere we can't get good perfection. Suppose take our hand is 5 fingers. These 5 fingers are all in similar size and also very close to each other. We can't do any work. So perfection is very essential. We have to see number of examples, plants, all anything. The perfection is very essential. Not only here, chemistry also the arrangement reflects perfection. So this study arrangement of atoms or groups in molecules that denotes stereochemistry. Stereochemistry denotes the arrangement of atoms or groups in molecules. The arrangement is not a 2-dimensional, it is a 3-dimensional orientation. The stereochemistry is the one of the powerful tools to explain the reaction mechanism and structure reactivity in organic molecules. Go back to our basic memory, that is isomers. What is isomers? So isomers is nothing but molecule have similar molecular formula differ with physical and chemical properties. The isomers mainly classified into 2 different types. The first one is structural isomers and second one is the stereoisomers. The structural isomers is nothing but a pair of molecules have same molecular formula differ in the structural aspect. This further classified into 3 types. The one is the chain isomers, the second one is the functional isomer, the third one is the position isomers. The chain isomer is nothing but a pair of molecules possess the same molecular formula with differ the chain length. For example, you consider about the N-butane and isobutane. In N-butane, the 4 carbons are arranged in straight chain fashion. But another molecule of isobutane, the 3 carbons are in straight chain fashion and other one is in the branched one. So these 2 isomers differ only the arrangement. The next is the functional isomers. Molecule or pair of isomers have same molecular formula, same structural formula, but differ only the aspect of functional groups. The molecular formula C2H6O denotes 2 molecules. The one is the ethanol, that is C2H5OH, and other one is dimethyl ether, CH3OCH3. The first molecule ethanol, the functional group is OH, that means alcohol functional group. The other molecule dimethyl ether possesses the ether functional group. So these 2 molecules possess same molecular formula but differ in the aspect of functional group. So this pair of isomer is called as a functional isomers. The third type is a position isomers. The position isomers, the pair of isomers have similar molecular formula and similar structural formula but similar functional group but differ only the aspect of arrangement of functional group in the main chain. For example, you consider a pair of molecules, one butanol and 2 butanol. The 1 butanol, the OH functional group arranged in the first carbon. Another molecule, the 2 butanol, the OH functional group arranged in the second carbon. So these 2 are a pair of isomer in the case of position isomers. The second main category of stereoisomers are 2 types. The first type is optical isomers, second type is geometrical isomers. The things arranged differ only the aspect of arrangement in the molecules. Optical isomers, a pair of molecules have same functional group but differ in the arrangement. The differ in arrangement due to the molecular dissymmetry. This molecular dissymmetry due to presence of chiral carbons. So next, what is the meaning of chiral carbon? What is the meaning of chiral? So chiral denotes valency of central atoms are filled by the different groups. For example, this molecule have 4 valency. This central atom possesses the 4 valency. The 4 valency of this carbon occupied by 4 different groups. So one is the green ball, other one is the red ball, so other one is the yellow, other one is the white. So the central atom have 4 valency. The 4 valency of central atom is satisfied by 4 different groups. So these type of molecules is called as the chiral molecules. The word chiral is used to designate the molecules. So we have some designation, lecturer, reader and doctor, something as like that. The word chiral designate the molecule have chiral atoms. The chiral atom means this molecule possesses the different groups. That is called as the chiral molecules. Optical isomers have same physical and chemical properties but differ only the aspect of the rotation of plane polarized light. So in this aspect, these optical isomers are classified into 3 main types. The one is enantiomer and other one is diastereoisomer. The third one is the diastereoisomers of mesoform. So what is the meaning of enantiomer? So enantiomer is nothing but a pair of isomers. It is also stereoisomers, no doubt. This pair rotate the plane polarized light in opposite direction with equal magnitude. So what is the meaning of that? These 2 molecules rotate the plane polarized light in opposite direction with equal magnitude means, suppose assume the one molecule, so suppose assume this molecule, suppose this is the lactic acid. So this molecule rotate the plane polarized light in clockwise direction with 90 bond angle means the other molecule rotate the plane polarized light in opposite direction, that means anti-clockwise direction with equal magnitude of 90-degree bond angle. So these 2 pair of molecules is called as a pair of enantiomer. And the other type, diastereoisomers. This is also a pair of isomers, no doubt. So these pair rotate the plane polarized light in opposite direction with different magnitude. That means one molecule rotate the plane polarized light in the clockwise direction, so other molecule rotate the plane polarized light in the anti-clockwise direction, but differ in the magnitude. Suppose one rotate the bond angle is 90 means, so other rotate the bond angle is 120 or 180 something. The bond angle is different. So these pair is called as a pair of diastereoisomers. The third chance is a diastereoisomers of mesoform. Diastereoisomers means the single molecule itself, one of rotate the plane polarized light in clockwise direction, the other half rotate in the anti-clockwise direction with equal magnitude. For example, in the tartaric acid molecule, 2 carbon is called as asymmetric carbon. In this 2 carbon, so one carbon rotate the plane polarized light in clockwise direction with some magnitude means the other carbon is rotate in opposite direction with same magnitude. So this is called as a diastereoisomers of mesoform. So in this mesoform, this molecule have a rotation, but the total rotation is 0. So doesn't meaning about molecule have not rotation. Molecule have a rotation, no doubt, but one half rotate the clockwise means other half rotate the anti-clockwise with equal magnitude. The total result is 0. So that's why this is called as a mesoform. So there is a internal compensation of this rotation. So this is the third type. What are the conditions of optical activity? 4 main conditions are that any molecule act as an optical molecules. The first condition must possess the minimum of 1 chiral carbons. So already told the chiral carbon, the meaning is so arranged with different groups. The second condition is must not possess any elements of symmetry. So any elements of symmetry means the symmetry element, there are 3 types. The first type is the plane of symmetry. The second one is center of symmetry, and third one is the alternating axis of symmetry. You cut the molecule or draw any line in the any place of the molecule, you get 2 halves. The one half is the identical with other half. That means one half is the mirror image of other half. So that time we will tell this molecule possesses the plane of symmetry or mirror planes. The other type is the center of symmetry. The center of symmetry means you start any point to go one side to reach an atom, the same distance we have to chance to meet another atom means, so this is called as the center of symmetry. The third type is the alternating axis of symmetry. So what is the meaning of that? So rotate the molecule through an axis with some angle, we get new arrangement. This new arrangement similar to original. So that time we will tell that molecule possesses the alternating axis of symmetry. So these are the symmetry elements. So our condition, the molecule must not possess any one of the elements of symmetry. And third condition is the molecule should not superimpose on its mirror image. So these are the three conditions any molecule act as an optical active compound. The next topic is the chirality. The chirality means any molecule should not superimpose on its mirror image. So that time we will tell that molecule possesses the chirality. The chirality means having handedness. For example, suppose you take our left hand, in the mirror image is the right hand. So these two is not a match. So this is called superimpose. So left hand is the object, so right hand is the mirror image. These two is not a match. So this left hand does not superimpose on its our right hand. So this is called as a superimpose. So any molecule act as a chiral molecule, it should not superimpose on its mirror image. The word chiral is used to designate the molecule nature. So suppose you are telling the chiral molecule means that molecule possesses one or two or some chiral carbons. Types of chiral molecules. There are totally 4 types of chiral molecules. The first type is the molecule having chiral carbon. The second type is molecule having the other quadrivalent atoms. The third type is molecule possess trivalent atoms, and the last type is the molecule possess the chiral axis. We will see one by one. The molecule having the chiral atom means the central chiral atom is a carbon. For example, the simplest example is lactic acid. In lactic acid structure we know that is a CH3, CHOH, COOH. The C middle carbon is a chiral carbon. This carbon having 4 different groups. That means the valency of this chiral carbon is filled or satisfied by 4 different groups. The second type of optical isomers is the molecule possess the other quadrivalent atoms. The first type is the molecule possess the chiral carbon. The second type is the molecule possess other quadrivalent atoms. So here also the molecule possess the 4 different groups, but the central atom is not a carbon, some other atom. For example of sulfur or nitrogen, as like that. For example of sulfur, that is a sulfonium salt. So sulfur having 4 different groups, and nitrogen means quaternary ammonium salt. So these two are the examples of the other quadrivalent atoms. And third type is the molecule possess the trivalent atom. In this case, that is a sulfoxide, 2 R group, 1 O group. So amines possess the 3 different groups. And fourth type is the molecule possess the chiral axis. Fourth type is different from the previous 3. So here the previous 3 molecule possess the some chiral atoms, that may be carbon or maybe nitrogen or maybe sulfur. But here the molecule must not have chiral atom but possess optical activity due to presence of the chiral axis. For example of in biphenyls and allenes and spirants, so these molecules possess the optical activity due to presence of chiral axis. So for example, you take the allenes. So allenes is nothing but 1,2-properdienes. In this molecule, the each end carbon have 2 hydrogens. So without having any substituents, this molecule possesses the 2 plane of symmetry, so optically inactive. So here also introduce 2 alkyl groups in the end carbon. So this molecule is also possess optical activity due to presence of the chiral axis. The third molecule is the biphenyls. So biphenyls we know 2 phenyl ring joined together in the bond joining axis. So here also without any substituents we know the phenyl ring is the planar structure. Without any substituents in the 2 rings, the both possess the coplanarity. That means maintain the planar structure. Suppose introduce in suitable ortho substituents in the 4 ortho side, there is the chance of steric hindrance. So due to steric hindrance, one ring is the planar structure, so other ring is the vertical structure. So without any substituents, both are maintain the coplanar structure. So introduce suitable substitutions due to steric hindrance, so one ring go to the perpendicular direction. So one is the planar, other one is the perpendicular direction. So here this molecule last is the planar structure. So this molecule possesses the optical active. So for example, in ortho position introduce one NH2 group and another side is COH group. So as like this other structure, other ring is also introduced these two suitable groups. So here this optical activity due to restrictor rotation. So without any substituents, this molecule is freely rotated. That is possess the planar structure. So introduce the suitable substituents in the ortho positions due to steric hindrance. So one ring go to the perpendicular direction, other is the planar structure. So due to introduction of these bulky groups, so this molecule possesses the optical activity. So this optical activity gives some separate name. That name is a attrope isomerism. The attrope isomerism is nothing but optical activity due to restrictor rotation about carbon-carbon single bond. So that case only in the possibility of biphenyls. So this is the fourth type of the chiral molecules. So already we discussed about the stereoisomers. In stereoisomers we have seen the basic things isomers and classification, that is the two types, structural isomers and stereoisomers, and each one classified into different category. The structural isomers divided into three types, that is the chain isomer, functional isomer and position isomers. The stereoisomers classified into two types, that is the optical isomers, or one is the geometrical isomers. So in this classification we have discussed about with suitable examples structural isomers and stereoisomers. So, and we have seen types of chiral molecules. There are totally four types are there. The first type is the molecule possesses the chiral carbon. The second type is molecule possesses the other quadrivalent atom, and third type molecule possesses the tetravalent atom, and fourth type molecule possesses the chiral axis. So this we have seen already.